We've all done it, right? You pull out your phone, tap a button, and just like magic, a car starts heading your way. But behind that incredibly simple screen is one of the most complex, high-speed, real-time systems ever built. So today, we're going to pull back the curtain and deconstruct the amazing engineering that powers every single Uber ride. It feels like it happens in an instant. But in that split second, your request is actually kicking off this epic digital journey through a massive global network. So we're going to follow that request step by step, from the moment it leaves your phone to the heart of Uber servers and all the way back. So just how big are we talking here? I mean, what kind of system are we dealing with? Well, Uber isn't just one giant computer program. Oh no, it's more like a constellation of over 4,500 individual little programs or microservices, all talking to each other, all working together perfectly. The scale is it's honestly hard to wrap your head around. And, it wasn't always this way. Like a lot of tech companies, Uber started out with just one big single application, what engineers call a monolith. But as they started growing all over the world, that just couldn't keep up. So you can see this constant evolution here. First, breaking up that monolith into those thousands of microservices, then moving everything to the cloud to get more flexible, and now they're looking ahead to create one unified system for all their services. All right, let's start the journey right where you do, with that single tap on your screen. Just imagine your ride request is a tiny little data packet that's about to go on an incredible adventure through Uber's digital world. So the very first place your request goes is something called the API gateway. The best way to think about it is like the world's most efficient bouncer and receptionist rolled into one. First, it checks your ID to make sure you're a legit user. Then it makes sure the system isn't getting totally overwhelmed. And then, like a genius receptionist, it knows exactly which of those 4,500 services needs to handle your specific request, all while juggling over 1 million other requests every single second. It's wild. Okay, so you're in the door. Now comes the real magic, the matchmaking. This is the absolute heart of what Uber does, finding the perfect driver for the perfect rider at the perfect time. And here's the kicker. It has to happen almost instantly. So how on earth does the system find drivers near you so fast? Well, the secret sauce is this really clever trick called geohashing. It basically takes your complicated latitude and longitude coordinates and turns them into a simple, short string of letters and numbers. And the real genius is that it turns a really hard and slow geographical search, like looking at a map, into a super, super fast text search, which computers are just brilliant. So let's break down how that matchmaking actually works. First, using that geohashing trick, the system instantly finds all the available drivers in your little grid square. But, not every driver is the right one. So step 2, it filters that list. Are they actually online? Do they have the right kind of car you asked for? Then, machine learning models give each potential driver a score. And finally, and this is the really cool part, a special algorithm kicks in. It's like a master planner for the whole city. It looks at all the riders and all the drivers, and instead of just finding a decent match for you, it finds the absolute best match for everyone, making the whole network more efficient before it finally sends that request to your driver's phone. And maybe the most insane part of all of this, that entire complex process, finding drivers, filtering them, scoring them, optimizing the whole system, all of that has to happen in under 50 milliseconds. That is literally faster than you can blink. The performance requirement here is just on another level. Okay, you've got a match, but the system's job is far from over. In fact, a whole new crew of services now comes to life to manage every single part of your trip, from the moment your driver accepts to the moment you step out of the car. At the center of all this is the trip service. It's basically the ultimate project manager for your ride. It keeps track of everything. Is the ride requested? Accepted? Is it happening right now? Has it ended? It's also the thing that's constantly recalculating your ETA based on live traffic data. It handles cancellations, stores your trip history. At the end of the day, this service is what makes the whole experience feel so smooth and predictable. And how does the system keep you in the loop through all this? Well, it's got a whole toolbox of ways to communicate. You get those push notifications that your driver is arriving. You know that little car you see moving on the map? That's powered by a super fast technology called WebSocket, feeding you data in real time. If something urgent happens, you might get a text message. And of course, there's the email receipt at the end. It's a whole orchestra of notifications, all designed to keep you informed. So, we've seen the mechanics of getting a ride, but humming along quietly in the background is this incredibly powerful layer of artificial intelligence. It's like a hidden brain, and its only job is to constantly learn and make every single part of the platform smarter. And we're not just talking about one big AI. It's a whole team of specialized machine learning models. You've got models whose entire existence is just to predict your ETA with spooky accuracy. You have others that calculate surge pricing based on supply and demand right now. There are even models that predict if a driver will accept a trip, or models that sniff out fraud. Pretty much every major decision is being helped along by machine learning. Okay, so we followed a single request from start to finish. Now let's zoom all the way out. What are the fundamental ideas, the core principles that allow this ridiculously complex system to not just work, but to work reliably, all over the world, all the time? This slide really says it all. It's like an iceberg. What you see, the functional part, is the simple stuff above the water, requesting a ride, seeing the car on the map, paying for it. But beneath the surface, that's where the real monsters are, the non-functional requirements. The system has to be available 99.99% of the time, respond in under 100 milliseconds, handle a million requests a second, and do it all across multiple continents. It's a massive engineering challenge. Now, to handle challenges like that, you can't just use a hammer for every problem. A system this complicated needs a whole toolbox. And that's especially true when it comes to storing data. Uber's philosophy is pretty simple. Use the absolute best tool for each specific job.
So for things that absolutely positively cannot go wrong, like your payment info or your user profile, they use a super reliable traditional database, like PostgreSQL. But for that constant fire hose of location data from drivers every few seconds, they use something like Cassandra, which is built for that kind of speed and scale. For data you need instantly, like who's on an active trip right now, that's kept in a super fast in-memory cache with Redis. The big takeaway here is that a one-size-fits-all approach would completely fail. The real genius is knowing when to trade off one thing for another, like consistency for speed, depending on what the job is.
So let's just recap with the jaw-dropping numbers. You've got over 4,500 services, a whole mix of databases spread across the globe, specialized geospatial tech, making location searches happen in a fraction of a second, and it's all running on a system that lets them do over 100,000 software updates a week. The combination of technologies and the sheer scale it's just mind-blowing. When you boil it all down, everything we've talked about comes back to these core ideas. Build small, independent services so teams can move fast. Design for speed and efficiency right from the start. Build your system around location data, real-time information, and machine learning. And above all else, build for resilience, because at this scale, things are always going to break. This is really the DNA of Uber's engineering culture. So we've just taken apart the system that moves people today, but you have to remember, this huge, intelligent, real-time machine, it's a platform. And with Uber aiming for things like autonomous vehicles and a single unified system for moving not just people, but food and packages and freight, the real question isn't just about how it works now, it's about what kinds of incredible problems a system this powerful will solve for us